Story time with Dawn here, which has kind of become the theme of the week. I don't know, but whatever. About a year or two or three or something within the past 5 years or so, whenever I'd have dairy products, I mostly cut them out of my diet right now, but whenever I'd have a dairy product, something with lactose in it, I would get violently ill. And then, all of a sudden, like within the past a little while, okay, I've had some lactose-adjacent products, even things that would make me violently ill before, and nothing would come of it. So it's like, okay, was I reacting poorly to something? Was it a specific bad run of something? No. Okay, because it lasted for like a couple of months there at a time, and I would get super ill. But then it's just not the case anymore. Same product, is same recipe and all that stuff. So what changed? Is this possible? I seen this article and I thought, hey, well, why not bring this to the forefront? We talk about gut microbiome a lot, so can it help reverse lactose intolerance? Sure seems like it. It seemed to be, at least anecdotally, a beneficiary of this process going on in my digestive tract. After childhood, about 2/3 of the world's human population loses their ability to digest milk, as far as we know, as far as we know, 100% of non-human mammals lose this ability after weaning. The ongoing ability to digest lactose, the main sugar in milk, into adulthood is a biological abnormality. Lactose cannot be directly absorbed into the intestinal tract and must instead be broken down into two smaller component sugars by an enzyme called lactase. Normally, the activity of the gene that produces lactase, LCT, declines after infancy. New evidence suggests that the decline occurs not because the genetic code is changed, but because the DNA is chemically modified so that lactase gene is switched off. Such modifications that affect gene activity while leaving the DNA sequence intact are called epigenetic. The epigenetic modification that turns off the lactase gene does not happen in lactose-tolerant individuals. This new finding gives an important insight into how lactose intolerance develops with age or after trauma in the intestinal tract. Interesting, and I'm never one to advocate for adding dairy products. In fact, I think that they're just a net benefit, mostly because they're just calorically dense, and then the nutrients that you get from dairy products you can easily get from leafy greens, okay, from other animal products if you're so inclined. It just doesn't really seem like it's adding that much, but if you are so inclined to add back in yogurt or some other types of cheeses that have lactose in them. And then again, if you find yourself becoming a little bit more sensitive to some cheeses, some drinks, some desserts that you not normally would be exhibiting those symptoms from. I can speak specifically about cheese, but again, if you can find a lactose or a dairy-free alternative, by all means, but specifically about cheese, the harder the cheese, okay, like this just might sound like an old wives' tale, but the harder the cheese, the less lactose that's in it, okay? So if an old slice of cheese, an old piece of cheddar out there is starting to make your guts act up a little bit, maybe switch over to feta, maybe switch over to Gouda, maybe switch over to sharp or an aged cheddar. The older and harder the cheese is, ladies, the less lactose that's in it. So the author of this is a microbiologist. I'm not. I just play one on television. And I became interested in the cause of lactose intolerance because it afflicts a close friend. He is of Norwegian descent, and like most Norwegian, is a genetically lactose intolerant. That's weird. I would love to see more studies on that, but that's besides the point. But he became permanently lactose intolerant at the age of 45 after a long regimen of antibiotics. Interesting. It's possible, even probable, that such trauma to the digestive tract can trigger the same epigenetic change that normally turns off the lactase gene in childhood. Scientists have found that other such cases of environmentally induced epigenetic changes, although more research is needed to establish the persistence and consequences of these alterations. Interesting, very interesting. Lactose intolerance is mostly due to your genes. Oh, okay. While the ability to produce the lactase enzyme persists into adulthood in only 35% of adults worldwide, this proportion varies widely among ethnic groups. We're about to get some racism up in here. In the United States, the proportion proportion of lactose intolerant people is about 64%, reflecting the mixture of ethnic groups that populate the country. The ability of adults to digest lactose appears in humans relatively recently. Specific genetic changes known as single nucleotide polymorphisms, SNPs, to your friends, conveying lactase persistence arose independently in various populations around the same time of their domestication of dairy animals. None of these SNPs are in the lactase gene itself, but instead are in a nearby region of the DNA that controls its activities. Scientists have been trying to figure out how these changes exert their influence over the gene's behavior. As you can see, there it is diagrammed out perfectly in a strand of DNA. How fun. Symptoms of lactose intolerance include diarrhea, stomach pain, cramps, bloating, and flatulence. Thoughts, that's funny. All of which result from a failure to break down lactose in the small intestine. The undigested lactose moves into the large intestine. Water enters to reduce the lactose concentration, producing diarrhea. The lactose is eventually eaten by microorganisms in the large intestine, producing as byproducts various gases that cause bloating, cramping, and flatulence. Recent studies have shown the symptoms of lactose intolerance can be relieved by some people changing in the population of their intestinal microbiomes, called microbiome. Interesting. Called microbiome. That makes more sense. To encourage lactose digesting bacteria, specifically bacteria called lactic acid bacteria. So that means if you work out your gut, no. Eat the lactose, but produce the byproduct lactic acid instead of gas. While lactic acid has no nutritional value, it does not produce the unpleasant symptoms of lactose intolerance. Interesting. The adaptation of the intestinal microbiome may be how some ancient pastoral populations with no genetic evidence of lactase persistence tolerated a dairy-rich diet. Ingesting lactic acid bacteria as a probiotic can alleviate the symptoms of lactose. Yeah, you see that around there. Things like Lactase, or that's the most popular one, but they're just basically a probiotic specifically with lactase in it. A promising new strategy is to feed the lactic acid bacteria a complex sugar that they can digest, but humans cannot. In initial clinical trials, subjects using this prebiotic reported improved lactose intolerance and had a corresponding shift in their intestinal microbiome. Larger clinical trials are currently in progress. So that's good. That's important. So if you're looking at adding or keeping dairy in your diet and you find that you have some sensitivities out there, it looks like there's some help on the horizon. So very interesting. And once again, the powers of your gut, the microbiome, the microbes that are in there, it's amazing. It never ceases to amaze me what it is that we're finding out about that and how much it really just affects your overall health. It's stunning, really. But with that said, thank you all very much for the gift of your time. I've been Don Consuelo. I want you to follow your gut and get after it. Take care, everyone.